院长 OK 咯？
好 ，OK，就在这边就好了，没关系。OK，好，可以。
好，那院长，我跟你介绍一下，我们刚刚有认
是
识一回。So here we have, totally we have 5 professors here. So the first, the Professor Chu, that your colleagues.
，Yeah，OK，Professor，nice to meet you。Yeah，
Yes, and 然后我们台北大学专这边还有2位老师。We have 2 professors from 那the NTPU, Professor Yao.
姚教授好。
Yes, Yao 教授 and Professor Kafana Chu.
Hello, Professor.
OK，nice to meet you，Professor
Nice to
Chu。
meet
Yes,
you.
and as I know that Professor Chen, he is very, uh, that very that high position. He that actually the associate dean or vice dean of the that NT
NTU，那是 NTU。
Professor Chen also as I know many in many association he also as a chairman or maybe sometimes should be the key important key man many of the associations, the academic or even sometimes very important in our country.
Thank you, Professor Yang, for your introduction.
Oh, thank you. 我可能好。So that welcome everybody here, and I will introduce one student, Gan Chen You. Again, he will introduce that process how remotely to manage the document. So 阿甘，好，阿甘，那请你开始。
好，大家应该都有看到我的画面吧？
有。
OK， 那声音应该也 OK。
有。
OK， 那好，那各位委员好，我是杨老师的一个研究生。我们可以看到我们这个 meeting 的右下角有一个文字讯息，我刚刚有放了我们的网络硬碟的网址以及我的 email， 大家可以点进去看看。这里面会有各个委员的资料以及一些档案，然后我讲解一下待会应该怎么弄。好，首先我们会看到这些档案，我们可以请各位委员先下载这3个，分别是评分表以及签名单以及考试费的表格，这个待会都会用到。再来呢，我们口试完之后，请各位委员将意见以及签名签上，还有这个评分要写上，之后用扫描或者拍照的方式上传至各自的资料夹中。再来，这个是口试委员的签名单，请召集人就签召集人的地方，然后其他的委员就签委员的地方。然后再请帮我把日期填写上去之后，一样扫描或者是拍照上传到资料夹中。
OK。
然后这个是签名单，口试费的签名单，因为它是一个 Excel 档，然后它会有2页，可以请委员是按到第2页，然后找到自己的那个栏位，填写一下自己的个资以及签名。之后可以上传到资料夹，或者是单独寄到我的 email 中，因为这里面有一些各自的问题，是都可以的。然后再来的话，就是会请各位委员去推选出一个召集人，然后先去下载这个考试成绩通知书的部分。然后因为这个学校的规定是需要召集人填写这个考试结果， 然后其他委员再签名即可。就是召集人一样要先签这边，然后上传到他的资料夹，然后其他的委员再去这个召集人资料夹里面下载这个层级通知书的版本，然后再去签名，然后再重新上传一次。然后大概就是这样子。
Okay, thank you. Thank you, Agan. So, so many documents. As I know, maybe four documents we have to sign. So, so maybe later, like, if we are in the process of the or in the process to manage the document, maybe Agan again can guide us to some help to us. Okay, so so we finished the section. We already the introduction and know how to we how to process. And so 我们现在可能要推一位召集人。We have to elect one chair for the section. So 教授the professors, do you have some recommendation? 我想我们请陈院长来帮忙好不好？院长不知道。
Must be outside our school, right?
Oh yes, conventionally should be outside our school. So Professor Chiu and Professor Chen.
Yes.
How about I recommend Professor Chen? Yes, actually that. Okay, so Professor Chen.
Okay.
Thank you.
Okay.
Thank you very much. Okay, so we go ahead. Okay, 那陈老师陈院长，我就把这个请您来主持了。好。
OK，那我问你一下，那个就是说他报告几分钟，然后讨论几分钟。我刚刚比较抱歉，因为我刚刚有进来一个重要电话，所以稍微那个阿干在讲的那一段，他前段有一些漏掉，不好意思哈。OK，那个年长会报告几分钟，然后我们 discussion 几分钟。
好，那个是这样子，就是我之前有跟你连打 ，its preparation maybe 40 minutes， 他大概会讲40 minutes，but maybe a little longer，然后我们讨论的时间就没有限制，那么应该时间是可以来得及，那所以40分钟，那院长这样好不好
？Okay, so let's start this meeting. And Nilansa,
yes,
could you
sir?
please will you upload some files?
Yes, sir, I can share with you all my presentation. Can you see my presentation, Professor?
Yeah.
Yes. Then shall I start?
Yeah, please.
Yes, thank you so much, sir. First, good evening, all of you, and very welcome to my my oral debate presentation. All professors, Professor Yang, Professor Chen, Professor Yao, Professor Chu, and Professor Kalpana. Thank you so much for joining with me at my special day, as well as my juniors and my classmates. Thank you so much join with me. I'd like to take this opportunity to summarize and present my research work, what I did during the last year. So this is my time. I will start to present my presentation. My thesis title is EEG signal processing for insomnia symptom identification and real-time sleep in onset detection. So actually, I want to mention one thing at the beginning. This research collaboration research with the Taipei Medical University and our department. So I would like to thanks again Professor Chen as well as Professor Yang giving me golden opportunity golden opportunity. So I will start my presentation. First, presentation outlier. There's a main two part. First is study case 1, EEG signal processing for insomnia symptom identification, and study case 2, real-time sleep in onset detection. Both study cases are related with the sleep in medicine. So during the whole research period, I repair American Academy of Sleep in Medicine document, and I aligned everything with the rule and regulation of American Academy of Sleep in Medicine. So I will start one by one. First, study case 1, EEG signal processing for insomnia symptom identification. Insomnia is the common sleeping disorders in society right now, and as well as rapidly going increased number of patients also. First, study case 1. Under study case 1, I will explain you research problem, research aim, research objective, research methodology, and finally research output. First, research problem. Sleeping disorders become a serious case in society and also rapidly going increase number of patients in society, as I mentioned before. So if someone thinking if he suffering from some insomnia or any other sleeping disorders, then they have to go to take a test at sleeping center in the hospital. After that, nurse will do a PHB testing. PHG measurement actually very complicated. PHB testing actually very complicated and also time consuming and also need special knowledge. So PHB measurement is like there's originally has 22 channels, and also you can see in this figure how they're doing the PHB testing. There's a lot of wires and other equipment, so those things are disruptive for the sleep habit. So also another special thing is that when doing the clinical testing at the sleeping center, it effect may case process for the collecting data. Why I am telling like that? Because sleep habit depend on the environment. I think you all have such a kind of experience, like you change your sleep environment, then your habit, sleeping habit also getting little bit changed. So that why I tell that measurement of the sleeping center, it is it may have case for the collecting data process, because a patient when go to their first time, he not familiar with the environment. So those are the problem we identify in this research part. So next, research aim. With earlier and accurate detection of insomnia, doctors can gain the valuable time to administrate medication and other treatment, as well as the patients, they can save the money, also time. So our whole research idea is the build a brain-computer interface that can home-based insomnia monitoring system with less EEG channels. Because of the less EEG channel, minimize the disruptive for the sleep habit, as well as he can use at home because of it is home monitoring system. So no need to stay at overnight at sleeping center. So it is easy to use at home. So this is our whole research idea. But research objective, during the first study case, we achieved 3 goals. First, evaluate and select the optimal feature set that can accurately quantify the difference between insomnia patient and healthy subject. And second one is the implement a model that can automatically identify insomnia patient based on the EEG signal. And third one, select the optimal channel combination that can accurately differentiate insomnia patient and healthy subject. And research methodology. First, block diagram of proposed system. There you can see main 4 modules. First, signal acquisition. Signal processing. Signal processing, there's a two sub-module, signal pre-processing and feature extraction. And other one is a feature selection, and finally classification. Signal acquisition actually very important thing in the EEG signal research, because our brain, each part has some specific function and tasks associated with that region. So when we doing the EEG signal research, first of all, we have to care, and especially we have to care the selection of the channel selection of the channel. So other rest of the modules I will explain in the next upcoming slide. First of all, signal pre-processing step. There is several pre-processing step we have done. First, filtering frequency range, filtering larger amplitude, segmentation, and finally normalization. Let me explain how and why we did those pre-processing step. First, filtering frequency range. We select the frequency range as 0.5 to 40 hertz. Why? Because of sleep in EEG signal frequency range is the lower level. It's like 1 to 40, maximum is 45 hertz. It's definition from the American Academy of Sleep in Medicine. And filtering larger amplitude, we got the cutoff marks as less than 260 microwave, because of signal with the larger amplitude happen because of the eyes movement or muscle movement. So signal with the larger amplitude considered as the noise signal. It is also definition from the American Academy of Sleep in Medicine. And segmentation, we did the segmentation into 30-second epoch with the 50 overlapping. And finally, normalization, we did the resampling at 128 hertz, because of we use 3 kind of data set. So each data set has own sampling rate. So we got the common sampling rate at 128 hertz. Next, feature extraction. In this research part, we extract the 3 domains features. First, spectral domain features, temporal domain features, and sleep-in data. I will show you to what are the features we extract from the each module in the upcoming slide. And feature selection. For the feature selection, we have used 3 methods. First, heat map, p-value, and t-testing. After that, we define the 2 rules to find the optimal features and top features. There's 2 rules. One, if t statistical is significantly greater than critical t-value and p-value less than 0.05 and Pearson correlation is significantly greater than with the category, then select as the top features. And second one is the if t statistical is greater than critical t-value and p-value less than 0.7 and Pearson correlation is high with the category, then select as the optimal features. And next, block diagram of CNN architecture. For the classification of insomnia and healthy person, insomnia patient and healthy subject, we propose the CNN architecture. So this is our CNN architecture. And experiment data. For this research, we use 3 kind of data. First, a TMU hospital sleep-in dataset, CAP sleep-in dataset, and Karate University sleep-in dataset from Germany. And below table, you can see some characteristic of our experiment data. All together, we used 100 data records, including 50 healthy cases and 50 insomnia cases. And here I want to mention one thing. At the beginning, we are suffering from the insomnia and as well as this healthy person data record. That time, Professor Chen gave us TMU hospital sleep-in data. So I would like to thank Professor Chen again for giving valuable data set. As well as I want to thank Professor Young and research output. Plus objective of I would like to show my research output with the group by objective. First objective is the select the optimal feature set that can classify the insomnia patient and healthy. First, spectral domain features. Spectral domain features we can divide into three groups. First, absolute power, relative power, and ratio power. Those are the features we extract from the spectral domain, and highlighted features are the selected. Finally, all together we extract the 23 features, and after that select the 14 features as the optimal features based on the our two rules. And second, temporal domain features. Those are the features we extract from the temporal domain, and highlighted features are the selected features. Finally, altogether 6 features are extract from the temporal domain, and finally select the 4 features as the optimal and top features. And also we extract the 2 features from the sleeping data, and all features, both features are selected as the optimal and top features based on our 2 rules. Altogether 20 features are selected as top and optimal features, and top 5 features. Top 5 optimal features: absolute slow wave power, zero concentrate, sleeping efficiency, total sleeping time, and mean value. Not only technical side, there's some evidence from the medical side to prove that. And objective to select the best fit model for the classify the insomnia patient and healthy healthy subject. For that, we did the comparison between our CNN model performance with the other existing classification method. We use RF, ANN, and SVM classification method, and also we use FE2 channel data for the experiment. And here you can see evaluation value with the respective each classification method. So CNN, our proposed CNN model got the high accuracy and other evaluation value. So CNN architecture is the best fit model for the classify the insomnia patient and healthy. And this is the CNN architecture we propose. Here is the including 10 hidden layers. It like 1D 4 layers, 3 max pooling layers, and 3 dense layers. And objective 3, find the optimal channel combination that can classify the insomnia patient and healthy subject. Here we use 3 channels data with the availability of our experiment data, and we use FE2 channel data from the frontal area, and we use C4 channel from the central area. And you can see here 2 figures including accuracy, validation accuracy, loss, and validation loss. How is the change with the time or epoch. So also I here mentioned that training and testing accuracy respective each channel. So I will do a comparison in the next slide. Here we use 3 kind of data set. First, C4 channel data from the central area, FE2 channel data channel from the frontal area. And first, this data set including only FE2 channel data here is the top 20 optimal pitches, and only C4 channel data. Here's the 20 optimal pitches, and here we combine all together C4 channel and FE2 and C4 channel. Here include 14 pitches after combining. So we did the comparison, and you can see in the FE2 channel got the high accuracy and other valuation values. So FE2 channel is the best fit model for the best data for the classify the insomnia patient and healthy. Here FE2 and C4 channel combining dataset got the less accuracy than other two, I think, because of the data overloading, because we are not change our CNN model architecture. We keep in the same architecture in the CNN model, but we change the data side, because here is a 14 features and these two have only 20 features. So there are no any biomedical any evidence why reducing this accuracy, but there are some evidence have to prove that why FE2 channel data good for classify the insomnia patient and healthy. And performance comparison with the other method. Other method mean we did the comparison with the other researchers proposed system with the other researchers system. They use different kind of classification method, but there's one special thing. They all use the sleeping state annotation when they're doing the classification insomnia patient and healthy. But we did the classification without using sleeping state annotation. Actually, sleeping state annotation is a time consuming and very complicated process. So we are focusing on the real-time application. Real-time application should be a simple, and so our proposed system is simplified version, as well as still have high accuracy. So those all about study case 1. So I will move to study case 2, real-time sleeping onset detection. This part we are focusing on sleep onset insomnia patient who cannot fall into the sleep within short time period. I mean within 20 minutes or 10 minutes. Patient. So under study case 2, I will explain you to research problem, research aim, research objective, research methodology, and finally research output. Research problem. I think you all have such a kind of experience, like last night you are not fall into the sleep within short time. Short time mean within 10 minutes or 20 minutes. You are waiting on the bed longer time, like 1 hour or 2 hours. Because of that, you are getting the lack of the sleep in the last night. So next morning day, your mood is irritable, and also you cannot focus on your work properly as normal, and you are some kind of getting angry with others because of the sleep mood. So those things happen because of the lack of the sleep. And also lack of the sleep not harm to the health for happen only few occasions, but mentally effect become a more serious after several sleepless night. So and lack of the sleep make a risk risk of injury and accident at home, workplace, and as well as on the road. So another thing is regular poor sleep would cause in serious health condition like heart disease and diabetes, and as well as some medical mental condition. So lack of the sleep makes serious problem as well as this accident. So lack of the sleep serious problem personally as well as society. So our research aim, smooth music can improve the quality of the sleep in the different age group. However, if if music playing after the onset of insomnia, it may interfere with increasing the probability of sleep arousal. So should be able to stop playing the music when sleep in onset has been detected automatically. So our whole research idea is the develop the system that can improve the quality of the sleep, as well as it help to fall into the sleep within short period, and also it can use at home. So in our proposed system, a key point is the find the sleeping onset point automatically. So in this research part, we propose the algorithm that can identify the sleeping onset point automatically. Next, research objective. During the research period, we achieved 3 goals, same as first study case. First, implement an algorithm for real-time sleeping onset detection. And second one is the comparison of the sleeping latency between the occipital channel and frontal channel. And third one, comparison of the sleeping latency between the healthy subject and insomnia patient. And next, move to research methodology. First, block diagram of proposed system. Here also you can see 4 main modules. First, signal acquisition and signal processing, and algorithm for the sleeping, identify the sleeping onset, and finally automatically identify the sleeping onset and also sleeping latency. Signal pre-processing has 2 sub-modules. Signal processing has 2 modules. First, signal pre-processing and feature extraction. I will explain you to in the upcoming slide. Signal pre-processing step. Here also same as before. Several pre-processing step: filtering frequency range, filtering larger amplitude, and normalization. First 2 same as first is study case, because both research cases are belong to sleep in medicine, so I will not going to explain again, so we can save the time. Finally, normalization. We did the resampling at 256 hertz, because of here we use 2 kind of data set, so it has on sampling rate, so we got the common sampling rate at 256 hertz. And feature extraction. In this research part, we only extract delta, theta, alpha relative power along with the 2-second shifted windows by using wavelet transform. You can get the more clear idea by this from this figure. We define the 2-second windows by using wavelet transform, and it can calculate the relative power each frequency band, and also it can move to forward. Research methodology. Algorithm of real-time sleeping onset detection. In here we define, in our algorithm we define the 2 priorities for identify the sleeping onset point. First priority is sleeping onset detection. In our algorithm, we define the sleeping onset point as first intersection point that alpha power decrease and delta power increase. You can get the idea, more clear idea in this figure. Red color represent the delta relative power, and blue color represent the alpha relative power. There's a 2 intersection point. First intersection point, delta relative power going decrease and alpha relative power going increase is not the sleeping onset point defined by our algorithm. In this intersection point, delta relative power going increase and alpha relative power going decrease. It is the sleeping onset point defined by our algorithm. And next, move to second priority sleeping onset detection. We define the sleeping onset point as first intersection point that alpha power decrease and delta power, theta power going increase. In figure you can see and get the more clear idea. In here blue color represents same as before alpha relative power, and green color represent the theta relative power. And this point, it is the first intersection point. Theta relative power going increase and alpha relative power going decrease. It is the point definition from the our algorithm. And experiment data, here we use two kind of data set. First TMU hospital sleep-in data set and CAP sleep-in data set. And this table you can see some characteristic of our experiment data. All together we use 100 data record with healthy 50 cases and 50 insomnia cases. Research output, same as per study case. I will show you the results with the group by objectives. So first objective is define the implement the algorithm that can identify the sleep-in onset point automatically. There's a two priorities. First priority sleep-in onset detection and second priority sleep-in onset detection. So first of all, I would like to show first priority sleep-in onset detection results. First, I show first results. Study results is study case. This study case belong to healthy female subject. Data record from the TMU hospital sleep-in data set. And you can see how is the experiment results. We use FE2 channel data for the experiment. And first part you can see original EEG signal after denoising. And second part you can see how is the relative power vary with the time. Red color represent the delta relative power and blue color represent the alpha relative power. And last part you can see show that power difference between the delta relative power and alpha relative power. And red star mark identify the sleep-in onset point automatically. And right side this table you can see how is the results. Sleep-in latency identified by our algorithm, it is 235 seconds. And sleep-in latency identified specialist by manually, it is 240 seconds. So they are not big difference. And one more results in the first priority sleep-in onset. This study case is an insomnia patient and insomnia male patient, and data record from the CAP sleep-in data. And you can see how is the our experiment results. Also here we use FE2 channel data, and here you can see original EEG signal after denoising. And here each frequency relative power, how is the vary with the time. And here same as before, power difference between the delta relative and alpha relative. And red star mark identify the sleep-in onset point. So right side this table you can see how is the results. Sleep-in latency identify our algorithm automatically 1183 second, and sleep-in latency identify specialist by manually 1200 second. And second, next move to the second priority sleep-in onset detection results. I will show you here. This study case is a healthy male patient, healthy male subject, data record from the TMU hospital. And here also we use FE2 channel data for the experiment. And first part you can see original EEG signal after denoising, and second part show that the how is the relative power vary with the time. green color represent the theta relative power, and blue color represent the alpha relative power. And last part showed that power difference between theta relative power and alpha relative power, and star mark identify the sleeping onset point automatically. And right side this table you can see results. Sleeping latency identify our algorithm automatically. It is 275 seconds, and sleeping latency identify specialist. It is 300 seconds. And one more study case belong to second priority sleeping onset detection. It is this study case belong to insomnia patient and also female, and data record from the CAP sleeping data. And you can see how is the experiment data results. Also here we use FE2 channel data, and first part is the original EEG signal after denoising. And here you can see how is the power relative power vary with the time, relative theta relative power and alpha relative power. And last part you can show that the power difference between the relative theta and alpha power. And red star mark identify the sleep. One 1,375 seconds, and sleepy latency identify specialist. It is 1,380 seconds. And research output objective 2, sleep in latency comparison between the occipital channel and frontal channel. We use FE2 channel from the frontal area, and we use O1 channel from the occipital area. I will show you to how is the results. First is study case 1. This healthy male subject, data record from the TMU hospital sleeping data, and you can see how is the results. This data record in the same patient, but 2 different channels data. Left side represent the FE2 channel data experiment results, and right side represent the O1 channel experiment results. And this table show that how is our results. By using FE2 channel, sleeping latency identify our algorithm, it is 345 seconds. And by using O1 channel, sleeping latency identify our algorithm 347 seconds. And sleeping latency identify the specialist manually, it is 360 seconds. There are not much different between the occipital channel and frontal channel. And one more resource, it is this study case insomnia patient and male, data record from the TMU hospital data. And you can see how is the experiment results. Here also same patient, but 2 different channel. FE2 channels also that the left side, and O1 channel experiment results in the right side. And you can see how is our experiment results. FE2 with the FE2 channel data, our sleeping latency identify our algorithm, it is for 76 seconds. And by using O1 channel, sleeping latency identify our algorithm automatically for 80 seconds. And sleeping latency identify specially by manually, it is 510 seconds. Here also FE2 and O1 channel sleeping latency not much big difference, so we are not see any significant difference between the occipital channel and frontal channel. So our conclusion is that both channel is good for the identify the sleeping onset point. And objective 3, sleeping latency comparison between the healthy and insomnia patient. For the comparison, we use healthy 50 cases and 50 insomnia cases. And here we see significant difference between the healthy subject and insomnia patient. You can see in this table, minimum sleeping latency in the healthy subject 1.88 minutes, and minimal sleeping latency in the insomnia patient 9 minutes, and maximum sleeping latency in the healthy subject 16.93 minutes, and maximum sleeping latency in the insomnia patient 37.48. So insomnia patients sleeping latency larger than healthy subject. So, and also one other special thing, patient normally healthy subject, healthy patient should be a sleeping latency with less than 20 minutes. Its definition from the American Academy of Sleep in Medicine. So insomnia patient sleeping latency greater, some cases greater than 20 minutes. And also you can get the more clear idea in this figure. Here blue color represents the healthy subject, and orange color represents the insomnia subject. So you can see in the here medium's value, there's a very big gap. There's a very big gap. So, and also you can see here some patient, some study cases results sleeping latency more than 20 minutes. And overall experiment results in the healthy subject. This is a healthy subject. Here we use also 50 cases for our experiment, and also we use O1 channel data. And here you can see how is our experiment results. X-axis represent the patient number, and Y-axis represent the sleeping latency. And blue color represent the sleeping latency identified by specialist, and orange color represent the sleeping latency identified by our algorithm. So there are no such a kind of big difference within the 150 experiment test cases. So our results is pretty much good. And second, overall experiment results in the insomnia patient. Here also totally we use 50 insomnia cases, and also we did the experiment with the O1 channel data. And same as before, X-axis represent the patient number, and Y-axis represent the sleeping latency. And blue color represent the sleeping latency identified by specialist manually, and orange color represent the sleeping latency identified by our algorithm automatically. And here results also pretty much good. And finally, sleeping latency prediction performance evaluation. We did the comparison evaluation by using balanced Allman plot. That theory said that time difference between the original and prediction time should be within upper line and lower line. So our here is the 100-day experiment record, 100 experiment cases. So all the experiment time different within the upper line and lower line. So our results is also our performance also good. And conclusion, there is a 3 conclusion. First, insomnia is the most leading sleeping disorders in society, and also it affects for both physical and mental health. And earlier detection of insomnia is helpful for both doctors and patients. And conclusion 2 is belong to study case 1. We analyzed on complete overnight sleeping EEG recording, and also we proposed the CNN model for the classify the insomnia patient and healthy, and we did the comparison and with the other existing classification methods. So finally CNN model got the high accuracy. And also we did the comparison between the with different data set. We used FE2 channel and C4 channel data, and after that combining all together, finally FE2 channel data got the high accuracy. That means FE2 channel data good for classify the insomnia patient and healthy. And also we find the optimal feature set that can classify the insomnia patient and healthy. And third one, it's belong to study case 2. We proposed a simple and accurate algorithm for the identify the sleeping onset point automatically. In this research, we calculate only theta, alpha, and delta relative power along with the 2 circle-shifted windows by using wave-load transform. And also we did the comparison how is the sleeping latency between the occipital channel and frontal channel FE2 and O1. There we not see any significant difference between the channel data. And also we did the comparison between the sleeping latency between the insomnia patient and healthy subject. Here we see insomnia patient sleeping latency greater than healthy subject. And finally, thanks to all the professors, Professor Yang, Professor Chen, Professor Yao, Professor Chu, and Professor Kalpana, listening and caring. I know you are in with the busy schedule, but you are giving me your valuable time. Thanks you so much again. And also I would like to thank especially Argan and Jason. You gave me big support during my research part, as well as Chamini, Eve, and Vepu and Sanaya. Also, thanks you so much giving me big support during my research period.
Yeah, okay, Niransa, thank you for your presentation. And now we will have discussion. I think Professor might have some question and also have some comment for you. So let's start the discussion. Could you, I think, could you please start from Professor Chu? How do you think about that? From you, begin.
Okay.
Yeah. Okay.
Thank you, Professor Chen, and thanks, Nilenta, for your research. I have some questions, but it's a little questions. For the research one, I agree that the early and accurate detection is important, and that home-based monitoring system seems very good. But I saw the age range a little poor. So my question is, because age or gender may be the confounding variable, will it affect your research result?
Yes, madam. Yes.
So how do you overcome these issues?
Actually, we are focusing on elder patients. No, I think more than 40 age, right? 40 to 60, like that.
I saw that your range is 37 to 77, 67.
Yes, yeah. I mean, it's depend on the yes, madam. It's because of our data record from different hospital. So actually, we are not consider about too much about age. How is the? We are not actually care about the age group, madam, because of the lack of the data.
Okay. Maybe you can just write it down to the limitation sections.
Yes, madam.
Okay. And also for the question about the confounding variables, I saw that the table 29 in your thesis is the summary of sample characteristics, and you just put the age and the BMI on the table.
Yes, madam.
So I want to know why you always keep the BMI on your table. Is because it's a very important issues, or
actually, because of BMI represent like he healthy normally in our society we are think he or she healthy or not. Basic thing is basic scale is the we are consider BMI is so that why I put BMI, because BMI represent the overall idea about the healthy or not, is not actual one, but is I just put it
or maybe you can put the importance about the BMI in your literature review.
Yes.
Yes. And my last question is.
Excuse me.
Okay.
Let's go to that table. I found maybe something wrong. Could you read? Yeah. We can find that about the BMI, all patients average is 32. However, in a healthy group is 29.2, and the insomnia group is 30.6. But I think it might be something wrong, right? Because the total number, I mean, 100 case BMI should between healthy and insomnia average, right? You can find that it should not be 32. How do you think about that, Nisan? Nisan, how do you think about that? I suggest you to check it once again.
Yes, sir.
Okay.
Yes, sir. Thank you so much.
Do you agree?
Yes.
Yes.
Yeah. Okay.
Thank you, Dr. Chen.
Yeah. Let's move ahead.
Okay, I have last question, and it's a suggestion about the figure 10. In your thesis, sorry, in your thesis, the figure 10, it talk about this cause of insomnia, but the reference is for aging adults. You didn't focus on the elderly, so I suggest to delete the figure 10. Figure 10. Here, this figure.
Yes, madam.
Yes, because it's for the aging adult. For elderly, the insomnia will caused by these reasons, but you didn't focus on the elderly.
Yes.
So yes, I think it may be different. So I just to suggest you to change the figure or to delete these figures.
Thanks so much. Yeah.
Okay, it's all my opinion. Thank you, Dr. Chen.
So
Yeah. Do you have further question or comment, Professor Chu?
It's all my comments.
Yeah. Okay. So let's move to next professor. Professor Yao, how do you think? Can you?
Yes. Yes, I indeed have some questions. And can you turn to page 14 on your PowerPoint slide?
$14.
14. Yes, 1, 4.
Yes.
All right. I see absolute power right here. And may I ask how to calculate the absolute power?
Absolute power, I mean relative. Real brain activity. Actually, we use Python predefined method to find the absolute power. And also in my thesis, I mentioned that the equation.
Yes.
It is actual brain activity in the brain. Actually, Professor, I to find the absolute power, get the absolute power.
All right, so you calculate the absolute power from the frequency domain, right?
Yes, yes.
Okay. And return to page 14. And the next, yes, can you scroll down? And yes, down. I mean 16. Let me look into 16.
16.
All right, here. And I saw mean value right here. And I suppose different individuals get different mean value. That is the DC offset, right? I just wondering how did you deal with different people get different mean value? Because I suppose from the brainwave, each person get different DC offset.
Yes.
Yes. For example, my DC offset might be exactly different to yours.
Yes, Professor.
Yeah.
Could I know the question again?
All right. If you measure my brainwave, I got an mean value, right?
Yes.
Yes. And if I measure yours brainwave, and I got another mean value.
Yes.
Yes. And as far as I know, the different individual, like you and I, got very different mean values.
Yes.
Yes. And how do you deal with that? I mean, maybe there is an offset. You have to minus an offset.
Actually, for the classification, we gave the with the label in our CNA model. We gave the label in the insomnia patient. This is the mean value, and also we give the label. He is patient insomnia or healthy person. So in this research part, I not consider about how is the mean value is the with the each person, Professor.
All right. So did you conduct some normalizations from your brainwave? Normalization.
Yes.
Yeah.
In the normalization, first we did the resampling because of different data set has different frequency sampling rates. So we got we use common sleeping common sampling rate, and as well as during the training process and before training we got the normalization with scaling normalization also.
Yes. All right. So you can answer me the mean value that was considered in the normalization step. Okay.
Yeah, we did all the thing we did, sir, Professor.
All right. Okay. And then turn to page 20. I mean 20.
20. Yes.
Okay. In this table, you showed FP2 channel and the C4 channel, right?
Yes. Yes.
All right. And I just wondering what is the difference between the insomnia and these two channels?
Yes. Thank
Is
you.
there any research?
Yes. Yes.
Did any research illustrate
Yes.
the importance? Yes.
Yes, I would like. Actually, it is good question, Professor. I would like to give answers. Insomnia patient and healthy person, main difference is insomnia patient has lack of the deep sleep compared with the healthy person. Insomnia patient lack of the deep sleep. Deep sleep area represent, Professor, frontal area, and during our sleeping, our brain activity start from the occipital area and go through central area, and after that come to the frontal area. So frontal area channels data represent and also delta activity. Mostly we can see frontal area. So insomnia patient frontal area delta or other activities less than healthy person. So that's why frontal area channel good for classified insomnia patient and healthy, Professor.
All right. And turn to page number 36. Okay, you already illustrate the relationship between the insomnia and those two channel, and why you showed O1 channel in this figure.
Yes, because
if you said FP2 and C2 are important, but in this figure you omit the FP2 and C2 and only showed O1 channel.
Yes, because FE2 and O1 both channel are we use, but we are not see any significant difference between the sleeping latency between the FE2 and O1. So that's why I show here only O1 channel experiment results.
Okay. And there are some I think there are some typos in your thesis, and I will write down on the sheet. But here I would like to illustrate some important corrections. Can you open your thesis? Yes, right here.
Yeah.
And then can you scroll up to the abstract? Okay. Oh no. Up. I think the abstract.
So the abstract, Professor?
Yes.
Yeah. This one.
Yeah. Here. Let me think. All right. You define the abbreviation of electron encephalography to EEG in abbreviation, right?
Yes.
All right. And the next, I think the next sentence. Okay, done. I think, all right, here you defined twice. So in the academic writing, the abbreviation, if you appear abbreviation when it first time appear, then you should use abbreviation throughout all theses.
Thank you, Professor.
All right. And then and page 8.
This one, Professor?
Yes. Up. I think the last sentence. All right. And can you see the last two sentences in this manuscript? And I would suggest you use in this thesis. The last second line.
In this page, sir?
Page 8. Page
It's,
8.
This one, 8.
Yes.
And
You just out of score in the end of page 8.
Here?
Yes. And the last sentence. The last sentence you say in this manuscript, right?
Yes.
Yes. I would suggest you use in this thesis.
Yes, thank you, Professor.
All right. And there are still some typos, but I'll wrote down on the sheet so you can go through them.
Thank
And
you, Professor.
those are all my questions.
Thank you, Professor.
All right.
Okay, thank you,
so
Professor
much.
Yao. And now, could you start your question and comment, Professor Setsu?
Oh, yes, Professor. Thank you. Thank you very much. Okay. Nilanta, thank you very much for your wonderful presentation. Okay. And your work is quite interesting. Okay. And I have few questions. Okay. So the first one, right, you say like, oh, we have developed a home-based insomnia monitoring system.
Thank you so much, madam.
Right. I was expecting you will show some system, you know, like
Yes,
if I want to use it home, right? How will it look like? The thing is like because you use some algorithm, right? You have to detect from the EEG signal. So if you want to measure the EEG, probably the 1020 system, right? We use, right? And there has been like many
Yes.
electrodes, right? We use. So in your case, you have optimized the electrodes. For example, the signal from FP2 or O1 or the C4, right? You have taken those
Yes.
signals. So if you say like home base, okay, so, and for example, okay, if I say I want to detect the sleep onset, can I use just only O1? Okay, only one electrode and just measure the signal and do the further processing. Is that possible?
I think Professor Kalpana, it is possible because I went to the Taipei Medical University Sleeping Center. They use on the American Academy of Sleeping Medicine. They said that use 22 channels, but normally when doing the actual process, they use only 4 channels, only 4 EEG channels. So in the medical side also use only 4 channels, 4 to 6 channels. I also refer the other researchers what they're doing, and also they suggest they also propose 1 channels, 2 channels is enough. But madam, there is one special thing. American Academy of Sleeping Medicine, they said that 10% of the population in the world, they haven't alpha brain activity during the sleep. So that in that case, we have to care about the other signal like EMG, body temperature, how is the EOG signal, like that, sir, madam.
I see. So you mean like along with the EEG, we do have to focus on some other signals, right?
Yes, madam.
Okay.
Yes.
So along with the EEG, okay, the connections and everything, so we need just a computer, right, to monitor the signal. Is it so?
Yes.
Okay,
Yes.
beside us. Okay, thank you. And about in slide 20, can you go to the slide number 20? Yes. 20. Yes. Okay, here, right, I was very like FP2 and C4, right? Yeah, I was like little bit confused. If we combine, right, these two data, like FP2 and C4, right, and the results are a little bit different. right? But you also say we don't know the reason why, right? Because you apply the algorithm for the FP2 and C4, you say this is like the accuracy is like 99, and if you use the C4 data, it is like 98.47. If you combine these two, how come it will be like 94.42? Yeah, I was also surprised. Yeah, I was wondering about this result.
I also thought, madam, there's a 20 pages in here. This here 20 pages. Here's a 14 pages and 100 data record. So that time I did many experiment. I thought that time because we are keeping the same CNA model. We are not changing the CNA model variables and other hidden numbers, hidden layers. We keep all the things fixed, and we only change the data number of feature set, madam.
I see.
I think because of that, I didn't see any evidence why it is getting less than like that, madam.
I see. Okay. Can you go to slide 30, 30? Okay. So here, right, you say the primary or the first priority, right, or the second priority. And I'm having a little question here, like the intersection, right, for the alpha and delta power, right? Alpha power and the delta power you define, right?
Yes, madam.
Is it possible, like, will it happen like less than 1 second? Is it possible? Maybe if your algorithm detects like this intersection, like less than 1 second, right? Is it possible?
Sorry, madam.
Can you hear
the
me?
connection.
Sorry. Yeah, there is some network problem. Yeah, at my office. Yes. Okay.
Me too. Yeah.
So there is like, yeah, you say that the alpha and delta, right? There is an intersection point, right? Yes.
Yes, madam.
Is it possible, like, if this occurs like less than 1 second, is it possible? Or usually it will occur only like after 4 seconds or 5. The time unit is seconds. Am I right?
I think it is not possible to happen after 1 second.
Less than 1
Yes, less than in our algorithm can find, but it is not in my idea is it's not possible to happen less than 1 second, madam.
Okay. And okay, 36, right? You say you compare, right, with a specialist, right? And your algorithm, right? The CNN, right?
Yes.
Here, the
Yes,
specialist means like, do they use any algorithm or
No, madam. Madam, you asking here.
Specialist, yes, specialist.
A specialist mean nurses in the sleeping center, madam.
I see. Okay.
They're doing the manual scoring system by using.
Okay. I see. So your CNN is like very similar to the specialist, right? Okay, fine. And also, right, you compare your algorithm, the convolution, right, the neural network, the CNN, with other methods, right? Like you say ANN or the RF, right? Yes. You compare and you say your accuracy or something is like better. Am I right? You had a table for that. Yeah.
Yes.
I am wondering, okay, is there any other study they do use a CNN, or only you're the first one to use the CNN, okay, for the insomnia monitoring or the onset sleep detection? Here, yes, this one.
Yes. In the one objective is our select the best fit model. That's why we did the comparison with the CNN and as well as the other existing classification method, madam. But I think other also use CNN model, but madam, they use sleeping state annotation for the classification insomnia patient and healthy sleeping state. They use sleeping state annotation. But it is process is a very complicated process. It is not good for the real-time application.
I see.
I think based on my study, I didn't see anyone who used CNN without sleeping state annotation, madam.
I see. Okay, so you could only see the ANN or something. Oh, here also you have mentioned, right?
Yes,
I
madam.
see. All are like with the sleep state annotation they do use. Okay,
Yes,
so you
madam.
could not find any other research based on the CNN, right? Okay.
Yes.
Make sure about this one. Yeah, if you find one, maybe you can add that in this table, the comparison table. Okay.
Yes, madam.
Yes. Okay.
I see other use CNN model or with sleeping state annotation. Yes, I couldn't find that one in the tables, madam. Yes, it is.
I see. Okay.
I can add.
Okay, okay, yes. If you have, you can add.
Yes.
Okay, and I have some in your thesis, right? I have some suggestion. Okay. And in page 35, okay. Can you go to page 35? There is a figure 13, right? Yes. Page 35. 35, page 35. Oh, yes, here. Okay. This one, like about the figure, right? The lines saying like with today's technology, the voltage produced by a, right?
Yes, madam.
It should be single cell, right? Or a signal cell.
Yes, madam.
It should be single cell.
Single. Yeah. Yes,
Okay,
madam.
yes, please change that one. Okay. And go to page 37. Okay, make a note of it. Maybe all your classmates can make a note of it. Okay.
Yes, madam. I also done.
Okay. Page 37. Okay. Page 37. Okay. Below the figure, right? Figure 14, you have written like a kind of last sentence, or in between, right? You have written the EEG signal values, right? Varies from 1 to 100 volts, right?
Yes, yes, madam.
Yes. So this one, it means like if we measure directly on the brain surface itself, or how, how we can get this high amplitude of signal, 1 to 100 ohms. You say normal adult, the amplitude of an EEG signal varies from about 1 to 100 volts. Is it so?
Actually, I got from the some medical report, some research reports, madam. Actually,
Okay, then you just put the reference here because
yes.
this value seems to be very high, or you have to mention the method, right? If you use the method, okay.
Yes, madam.
Yes, yeah. So this one, okay, and then page number 39, okay. Page number 39, okay. The reference is 40 and 41, okay. The reference 40 and 41, okay. Okay, like
Yes.
the referential montage, right? You define about the montages, right?
Yes, madam.
Referential montages. Okay, why you show the reference at the beginning of the sentence? Okay, this is quite confusing. Maybe you can arrange this one. Okay, and also, okay, could not find the references. 40, I cannot find. Also, 41 is not related to the montages, I think. Yeah. Okay, please check these references. Okay.
Okay, madam.
Yeah, 40 and 41. And also, you see here, it should be like 2008 or something, right? Yeah, the year, right? You mentioned. Am I right? Name
Yes, madam.
and okay, please check this one. Okay.
Okay,
Yes.
madam.
And also, everywhere, check the references. Okay, somewhere it is like, yeah, this way. So check all the references. Okay.
Okay, madam.
And then, okay, in page number 40, okay, 40. Okay, here, okay, in the first sentence, I mean the first paragraph, right? You have defined the the delta, theta, alpha, and beta waves, right?
Yes,
in
madam.
their frequency range.
Yes, madam.
Okay. You have to mention the reference here because in
Yes,
in
yes.
some theory, right, we also say the delta wave may be from 0.5 to 3.5, right?
Yes, madam.
Yeah. So yeah, please show the reference, okay,
Yes.
from where you define this range. Okay.
Yes, madam.
Okay. And page number 42. Okay. Yes. 42, right? Figure 16, right? Okay, it's coming under 41 and 42. Figure 16, right? Can you see examples of these EEG rhythms from top to bottom, delta? Can you see figure 16?
Listen.
Yes, figure 16. Yes, this
Yes.
one. Okay. And this one you have taken from other reference, am I right? 42.
Yes.
Okay. But it seems that this is not in this reference, this figure. Maybe check it. Okay.
It's no. I think it's wrong. Not. I mean, not. I got from the reference from that.
So you plot this figure or?
No, I got from. Yes. Yes, madam. It is. I think I have to consider. Thank you, madam.
Okay, please check this one. Okay,
Yes,
please
yes.
check it. The corresponding reference, is that correct?
Yes, madam.
Yes. Okay. Yes. And then okay. Also equations, right? In your algorithm, right? You have defined many equations. Okay. So there also, right, if necessary, you have to add the references, right? Because whether you define the equation, okay, or in your algorithm, okay, so you have to check those things. Yeah.
Yes, madam.
Okay. I think, yes, and also you mentioned like the Butterworth filter, right, in your thesis or
Yes,
also in
madam.
your presentation, right?
Yes,
Maybe
madam.
you can show some specification or something, right? Yeah, those things related to the Butterworth filter. Yeah, you can
Yes.
mention. Yes. Okay, I think that's all my suggestion. Okay.
Thank you so much, madam.
Yes. Okay. Thank you, Nilanta.
Thank you so much, madam.
Okay. Thank you. Thank you,
Thank you,
Professor Chen. Yes, and
Professor Cesar. Thank you. Yeah. Okay. And now, the most important advisor, Professor Yang, would you please also give Nilantha some comment?
Oh, thank you, Professor Chen. I think that mainly because I already that we cooperate to check the thesis maybe many times, but I think today I also received not only Ninenda but also I also received some still not incomplete or not so maybe something sufficiently in the thesis. So maybe later that Ninenda maybe I also together with Ninenda to revise and correct. I think for me that I think that my point is that sometimes I together with Nilenda I do the he write the thesis and sometimes we still a little not very comfortable, not very confident that the value from the medical side. So sometimes that we cannot not that the values, the contribution of the thesis. So I know here many professors your research related to the to the medical. So kind of your suggestion should be very important to us. So I'm listening, more like that. I'm listening, not I give the suggestion here. So, but I think I received a lot already. Thank you very much.
Thanks.
Okay, thank you, Professor Yang. I think finally I would also like to give Nilanza some comment. The first is that in the page 39. About the conclusion in the column 01, you mentioned that insomnia is the most leading sleep disorder in the society. I think it is correct. In here, you list three points, three opinion, but I think it is opinion, and it is not the conclusion of your study.
Yes, yes.
Do you agree? Yeah.
Yes.
Yeah. So I suggest you can mention it, but you should not list all of these points in your conclusion.
Yes, Professor.
Yeah?
Yes, Professor.
You didn't do that?
Yes,
Yeah,
Professor.
I think you have sufficient good result already. So I think you don't need to list this 3 points. Yeah, okay.
Thank you, Professor.
And the second is that in the development of recent year, many small devices, for example, just by using EEG signal, we can measure and we can measure that ECG, and from the signal processing of the ECG, we can correlate with many channel signal from PSG, and they will have they can establish the same conclusion and the same result of the situation of our physical condition, you know.
Yes.
So even in these years in Taiwan or in the worldwide study laboratory, there are a lot of researchers study in this field just by using a kind of biosignal, and from the single biosignal they can analyze and can computing this signal, and by signal processing and some AI process to give very similar result from the multi-channel PSG. Yeah, you can mention that because you want to devote yourself in the study of the sleep medicine and in the field of electrophysiology. I think you need to have this concept, and you need to know the new trend of the study. Yeah.
Yes, Professor.
Okay. Yeah. Okay. This is just to be a comment. Yeah.
Yes, Professor.
And the third is that I would like to suggest you to publish the result and submit the result to some international journal. Although your study method and all the discussion and conclusion is still need to be modified, but however, you do it very well.
Thank you,
Yeah.
Professor.
Good job.
Thank you,
Yeah.
Professor.
Good job. Yeah. That's my suggestion and my comment.
Thank you so much, Professor.
Okay. Yeah. So, Professor Yang, should we stop here, and we are the committee will discussion and let all the students leave this discussion.
Okay. Okay.
Thank you.
So, yes. So,同学们现在就可能要请你们先离开一下，因为老师们讨论一下那个怎么打针机。那个阿甘，你留下来，你留下来一下。那么等一下，阿甘你再把同学们叫回来，这样就好了，好吧？那我会跟阿甘，我就等一下你来场控这样子。好，那么其他同学，那就是请各位先离开，先离开。
And I think Ninansa needed to
Yeah, Ninenda. Yeah, you also have to
be in contact, and maybe you need to come back to the platform, the discussion platform, after our discussion. Yeah.
Thank you.
Is that right, Professor Yang?
Oh, sure, lad. Yeah, he already did.
Yeah. Okay.
Yeah. Okay. So, just we remain here, not professors.
Yeah. Okay. So I think every professor give Ninansa many important question and suggestion and comment. From this discussion, I think Ninansa can improve his thesis, and it will become better. As my observation, Ninansa is a very good student. Yeah, Professor says you teach you taught him very well. Yeah, he is
No.
very excellent.
Yeah, actually, many professors here actually also contribute a lot of the effort to persuade him, or even sometimes justified or some kind of the advice to him or even to me. So I thank you, everybody here. Many thanks. Yes.
Okay. Thank you. And Ninansa study with very high enthusiasm, and study very hard. And
Hey, no sound.
yeah, his speed is quite prompt. Yeah, and Professor Yang taught him and cooperated with him very well. And I think Ninansa learned a lot from Professor Yang. Yeah.
Learn from many people here, not only from me.
Yeah. But however, I think Ninansa still have a long way to study in the field. So I would like to ask every professor and especially ask Professor Yang, should we proceed to next step to decide the score of Ninansa, or what should we do now?
Oh, I think that it should be independently that everyone give that from his idea, from professors, the committee, everyone, the member, the score, not independently, not from my suggestion. I have no suggestion. I have no direct suggestion to make the score. But the problem is that we conventional. Before one student also have the process. We do this kind of process. In Chinese. 我们是把分数打在旁边这个 chat box 里面。那当然，每一个人把自己想要打的分数打在这个 chat， 因为等一下主席要拿着平均分数跟那个李念达恭喜嘛。那就是等于说我们个人表现的分数，大概就用这个 chat box 那个有个 messenger 那里，然后 每一个老师自己 independently 就是每一个独立打在这里，然后主席或者我们请阿甘再帮我们评选。
好。
那实际上子会不会主席好不好？我觉得是
OK。好，杨教授比较不好意思，因为刚刚阿甘在讲的时候，还有前头在讲的时候，我这边刚好有电话进来所以被干扰到了一个重要的电话进来，那被干扰所以程序上我那时候没有听到，只知道好像有很多表单要填。
那个阿甘还是再带我们一下，就是说我们现在是不是先打成绩，然后后面等一下阿甘在不在？
可以。
阿甘等一下再帮我们带一下那个
这个程序，
其他的 document。
好，那杨教授是不是我们现在就先进行这个 chat box 的这一个分数的Professor says now we would ask you to decide the score for Nilansa's presentation and for his study, and you can decide the score and send upload by the chat box. Could you find your chat box and
but we have to fill it in the document, right? There is a
yes, still we have to finish the document, but now because we have to have the final score, average all the committee members the score.
Just to be the first step only.
see.
Yeah. Okay.
So it's temporary we put here, and later we finish the document.
I see.
Okay. So everyone send your score from the chat box. Okay.
OK， 我最后好不好？因为我不能当前面。
好，那我就先送了Okay. So now we have 5 score from 5 professor. And 阿甘，你是不是可以帮大家稍微就是整理下来一下好吗？好，那杨教授，我们下一步嘞，来你来带一下。
那要下一步的话，我们请那个陈佑、阿甘你来带好了。Professor Kafana, he may be in Chinese.
Oh, okay.
Yes, but I can do the translation.
Okay, it's fine. It's average, right? It's okay.
阿甘在吗？
可以。
来，你帮大家带一下。
就是大家应该都有这3个档案的。然后
这个档案在哪里？
在那个我们文字讯息里面会有。
So in the chat box that the Agan already give us the Google Drive the address of Google Drive.
对，然后点开来会是这样。
Yes.
是在 email 里面是吧？
不是在这里，在这一个 chat box 里面。
在这 chat box 里面啊？
在 chat box 里面
already 上面吗？
Yes， 往上滚。
OK， 就是硬碟网址的地方。
Yes.
OK， 那我们就把它打开，是不是
？So Professor Kavana is okay?
Oh, I think this Nilanta he already sent the link. Is that the same link?
Yes.
Oh, yes, Professor.
Okay, then. Yes.
好，那阿甘，我们接着是先开哪一张？
首先
我看到这边有5个是口试评分，第6个是口试成绩通知书，第8个是我们是各自开各自的去写吗？还是怎么样？阿甘能不能带大家一下？还是现在是开哪一个表单？
现在我们先从这个口试评分表开始。
好，就第5个嘛，口试评分表。
是，对。
好，那我们就开第5个口试评分表啊。
这边会需要委员们帮我填一下意见以及评分，然后这边帮我签名， 然后是扫描上传到资料夹里面，或是拍照上传到资料夹里面都可以。就是
能不能填入直接送出？
什么？
可以填入，然后直接 upload 吗？
可以，可是这个签名的部分需要是亲笔的签名，或是电子的方式。
哦，好，所以是要事后作业吗？
嗯，对。
那这个是，就是说，如果是这个地方很重要，就是这个签名。那个可能老师们，我先前的一份的做法是我用手签的，但是有些老师他们有一些那个 Acrobat 的电子签名，那他们用 Acrobat 的电子签名就不用印出来 scan 这样的程序，但是签名好像都是必须要签完这 document。然后阿甘的做法是，阿甘你是就把它再上传到这一个 Google Drive 里面。那阿甘你也再解释一下要怎么上传。
就是我们各个委员都会有一个各自的评分表，然后会有各自的意见以及评分，然后我们委员签完名之后，可以就是用扫描或者是拍照的方式上传到这个云端里面的委员的资料夹里面。
这里阿甘已经做了每一位委员的一个 subdirectory subfolder for every committee member. So we update directly to the subfolders.
请问一下，所以我们是可以上传 PDF 吗？
可以。
然后我请问一下，就是说那个多久？就是说有没有一个时效，一个时间点？就是说多久之前要上传？
你帮我改一下中文好吗？李全，
时间的话，就希望各位委员就是尽快，因为有关就是学长一些要办一些毕业的手续之类的。
对，我跟各位提醒一下，就是 I just remind because Ninenda already booked the air ticket to go back to Sri Lanka. So August 1. So maybe we are limited to the time to deliver our score, and he can be finish all the process process and leave the school, graduate completed. 因为那个姚老师他可能有，我们尽量快早一点给他是对的。
那要不要直接给我们一个 deadline 这样？
我们 deadline 就到，要不然我们2天3天好了，好不好
？OK， 好。
3天，我们就今天开始这样子，后面3天到22号。
好。
22号，好。那个姚老师好吗？
可以啊，可以。对，因为我这边没有印表机，我要到学校去印了。
另外想要确认一下，就是我们的那个建议是要写中文还是写英文呢？
都可以。
好。
OK， 阿甘再继续哦。
好，然后会有一个是口试委员签名单，这个应该是第8个。就请陈院长签召集人这边，其他的委员就签委员这边。
这个是在怎么样的一个签法？是现在就先直接打上去，还是你要怎么进行？
我们学校现在的做法他说他就夹5张了，他就每一张都夹上去，他没有姓名签在同一张，
就各自签各自，然后就夹上去就好了。
对，他就夹5张。
也是印出来，然后签回去吗？
是电子签名也可以，
电子签名也可以啦。好，那就是电子签名之后把它弄成 PDF， 然后就送回去这样子。
是的。
好的。
阿甘是不是这样子？
对。
那我签，因为委员有3个嘛，我们 overlap 还是要分好？我签第几个之类的要吗？
这个是没有特别的规定。
没有关系啦哈，
没有关系
不然每个人都签在第一格好了，这样可以吗？是吗？杨老师可以吗？
好，可以。
那就比较不会有
好啊，那我们都是签在说all the committee members just a first， 就是第一个栏位 the first column。
委员的第一栏位。
召集人要在院长你要在召集人的位置啊，我要在指导教授的位置。
好，我在召集人的位置哈。
是。
好。
然后这个日期再麻烦帮我填一下。
日期也要填。
对。
好。
然后下一个这个是有一个口试费表单的部分，就在这个有一个 Excel 档，然后它是会在第2页的部分会有一些身份证字号以及一些个人资料要帮我填，然后这里一样要帮我签名。我刚刚有去看了一下，那个邱教授好像已经上传了，可是他是没有签名的版本。
好，我等下签名。
你那场你是说刚刚那个是第5个，然后刚刚是口试委员那个是第8个嘛？哈，那现在是第几个？
这个他没有标第几个，
他是写什么？
他是会这考试费表格1100705这个。
哦，好 ，OK， 好，那所以实际上大家要完成的就是这边所看到的5、6、8跟那个跟你那个110、07、05的那个考试费表格的部分是吗？这是4个表，还有跟大家各自的那个你要我们拖上去到云端的那一个部位是这样子吗？
是。
好，所以基本上来讲，今天我们是不是也差不多了？反正大家就是各自把这个5、6、8跟考试费的表格这个部分填好，那然后 scan 好，还是说用成 PDF 好了之后，然后就是寄回去哈？是用 email 寄回去，还是通通拖到我们每一个人各自的那个里面去？
拖到我们的硬碟里面是最快比较方便。
就是这4个弄好之后就通通拖到自己的名字里面去。对哈。
只是那个关于有一个是考试成绩通知书，这个是需要陈院长先帮我们填写，因为他有一个是这个考试结果是需要召集人来填写的。
是，好的。好，
这个地方我解释一下，就是这一张是他学校规定是说这一张那个就是召集人要先签现在这一个框起来红色的位置这里要先签，然后召集人在您的签名之后，那阿甘会再送给我们，所以我们其他4位委员拿到已经有你的签名，我们在你的签名旁边我们再签。
OK，
等于说这一张是你要先签，因为这里有一个成绩。
老师你在讲的，等一下，我不晓得会不会弄错，就是说那个召集人那一张，召集人还有委员还有指导教授那一张吗？现在是那一张吗？
就是现在阿甘你在秀那一张，阿甘秀那一张，阿甘，对，这一个是叫做成绩通知书。
好，
他成绩通知书里面他的做法就是等于站在召集人已经打好分数，那所以您签了名之后，我们其他委员在您的签名旁边我们再签
，OK，
完成。
所以这个看起来怎么样？是要事后再作业了，还是我赶快我就先把
我们现在赶快算大概就阿甘现在算出来这是几分？一共
平均是90分
，90分哈，所以就是90点多少吗？还是刚好90
分整
？90分整。那个就是陈院长，等一下您就可能在这边先写，好像也要写中文哦，好像用中文写
大写的中文90分哈。
对，然后您签名之后，那阿甘那个陈院长做完要怎么做？
就是陈院长帮我签完名之后，帮我上传到您的资料夹。
好， 我看这样子好不好？就是说，就是说哈，你那个硬碟网址的位置有寄 email 给我们吗？有哈，好的，好，那这样好了，那我们今天是不是我现在赶快作业，把这些的东西哈，就赶快弄好之后，我就赶快把它丢上来，那先给杨老师赶快确认看一下，这样子是不是 OK？然后每个老师也就自己可以的部分就先作业，要不要现在就作业呢？还是要事后作业？事后作业也是可以的，就是说。因为可能大家也忙哈，就是说事后作业，就是说我先把我的部分就是每一个人把自己各自的部分就是弄上去然后有牵涉到需要我先签名的部分，我就弄好之后再麻烦阿丹来通知各个老师，让各个老师来用这张我弄上去的这张来签，这样对吗？还是阿甘帮我们都弄好哈？那就是因为我看那个表单好像现在还很多都空着嘛哈。好像连那个题目好像还没有打上去哈。
阿甘有打了吗？应该你不是有事先做好吗？
有那些云端上面档案都是已经打好的，我 PPT
都是已经打好的，
上面的是空白的。
OK， 了解。所以在云端上面的都是打好的哈。
对，
现在去看一下。
然后我已经请学生这样，那我们现在就请那个
好的
主席院长帮我们跟Nilanda 讲一下话。
好。抱歉了，我第一次用这个那个线上的这种台北大学的这个系统啊。
对不起，可能不是很好。
不会，反正是疫情时代比较特别的时候。Nilanda now you are online already. I would like to give you the greater congratulations.
Thank you, sir.
You get a high score.
Thank you, professor.
Every professor, I think every professor are satisfied with your presentation and your study. But however, you still have some insufficient part to be further improved. But in general, you got a high score, and everybody confirm your very good performance. And we wish you will have a very promising future after you go back to Sri Lanka, and you can continue to study in the sleep medicine field, and also you own the ability about sleep medicine study and about the signal processing, and also data management, and I think also some AI technology. Yeah.
Thank you, professor.
Yeah. Everybody confirm your good performance, and you really do a very good job. Yeah.
Thank you.
Congratulations. Yeah.
Thank you so
I
much.
think, however, Professor Yang should also give Nilanda some comment. Yeah.
Okay, I think thank you. I think that just congratulations, Nilanda.
Thank you so
yes,
much. Yes,
actually, your effort deserve, and everyone here very positive. The quality you present in the thesis. So good job.
Thank you, professor.
Yes.
And
congratulations.
Thank you, professor. And also, I want to thanks all the professors showing me my mistake on my thesis, and also valuable comments. So I will do a correction, and also I will consider your valuable comments when I do in future research. Thank you all the professors, and especially Professor Chen and Professor Yang. Thank you so much giving me golden opportunity. Actually, this is my dream research area, signal processing and EEG signal brain technology. Thank you so much Professor Cheng, and also Professor Yang, and also Professor Chu, Professor Yao, and Professor Kalpana. Thank you so much. Your valuable advice and comments, and also showing the mistake.
Yeah, and I also would like to invite Professor Setsu to give us the important address.
Thank you very much, Professor Chen, for giving me this opportunity. Okay. And Nilanta, first of all, congratulations, okay, on your
Thank you very much.
successful graduation. Okay.
Thank you so
Yes,
much.
I know you worked very hard. Okay. And also I should congratulate Professor Yang. Okay. Yes. Okay. And also thank you, Professor Yang. I think he guided you like very nicely, and your presentation shows your hard work, and also Professor Yang's, like his guidance. Yes, it's kind of very wonderful. And keep in touch with us, and also keep in touch with NTPU, especially. Okay. Yes,
Okay.
and all the very best for your future endeavors. Okay. Yes.
Thank you so much, madam.
Okay. Thank you. Thank you.
Yeah, okay. And finally, Professor Cho and Professor Yao, do you like to say something?
Okay. I go first. I think you already done a good job, and hope you can go far in your home county. Okay.
Thank you, Professor.
Professor Chu? Professor Chu?
Hi, hello, Nilanta. Congratulations.
Thank you, Professor.
Okay.
Yes.
It's too noisy in my place. So excuse me.
OK，OK，那个 Professor Yang，你给我们一个 closing remark 好不好？哈 ，OK，那就结束哈。
I think that in Chinese I say maybe in English okay. I think that not only Nilenda, I think everyone here because I know everybody here should not the first time not talk to Nilenda. So I know many stories in that we the friendship between the Taiwan's professors to the Nilenda. So I think that we appreciate each other. So Nilenda,
Yes.
are you here?
Yes, sir.
So I think that maybe you are more. I know. Maybe you know much more than before professors in Taiwan. So
Yes.
respectable. So I think that afterward you go back to your country, have a good friendship continuous there to the professors, everybody here.
Yes.
Okay. And for me that I just say thank you for everyone here. Thank you very much.
Thank you all professors.
Yeah, OK。那杨教授，我们是不是就这边
那我们就好，就谢谢。
那我这边的话，大概每个老师基本上在让那个阿甘在跟每个老师 contact 哈。那我们把那个表单大家就完成，那可能交上去，然后给阿甘，那然后阿甘再协助做这个整合联系。杨教授这样好吗？
好，谢谢。
好，那我们今天就结束了哈。
好，
那你跟大家宣布吧。
好啊，那谢谢主席，也谢谢各位老师。那我Nilenda, we finished your the defense, so very nice.
Thank you so much, Professor.
Yes, we finished.
Thank you.
Okay, so we finished that. Okay. So
congratulations.
Bye.
Thank you.
Thank you,
Thank
every professor.
Thank
Thank you.
Bye bye.
Bye bye.
Bye bye.